question, are all of those attributes relevant to class, right? So sometimes when you have redundant attributes, it goes down the algorithm execution. So what we're going to do is I'm going to run the perceptron algorithm, but first, that's a class variable. And two classes, D, E, right? So here it tells me how many instances of each class I have. So 325 and 126. So in this, I'm not sure what those 825, 827 are, but I see that in some data set they do that to perhaps person confidentiality. What I do now, I'm going to go to the classify screen, and I'm the neural network algorithm. So I'm going to select percentage split test option, and it's because I'm going to be doing a GUI, graphical user interface. Select cross validation, I'll be doing it 11 times. I'm going to show you in a few. So I'm going to go here, choose, and that this algorithm is in function. And I'm multi-layer perceptron, all right? Think about it. What am I expecting to get, right? I'm asking how many classes do I have? 2, right? So I'm going to get an output for each class, right? So first I'm going to click on more options. I'm going to say, okay, I want to see, for classistics, I want to see the model. All right, you want to make sure this is checked. You want to see confusion matrix, and you want to be able to visualize the model. So you want to make sure this one is checked. Okay. So what I'll do is I'll double click on this text box and that's for the algorithm. So at any time, if you're sure what these are, you can more. And if you use the synopsis of the algorithm, what's perceptron? See, it explains you here and tells you what each option does in detail, right? So that's first. And here is the capabilities. Tells you the types the algorithm work with, right? So I'm going to select true. And note that here is a specified number of the hidden layers, and there is one wildcard. Here, if you click on more, it can explain you the details, what each wildcard is. Image is meaning. So basically, A means the number of nodes in a hidden layer is the number of attributes plus number of classes divided by 2, right? So you can look at the pre-process tab and see how many attributes you have, right? And 2 classes, and then you divide by 2. That's not what it means. So your wildcard here. So both network is going to have one hidden layer. Heat rate and momentum, they determine the speed of network. We're going to see that in a few when we're going to be doing, when I'll show you the graphical user interface. But 2 guys right here affect the algorithm itself, right? So I'm going to call it. It tells you that I want to run the algorithm for 500 repetitions or until the error rate converges. So kind of like a stopping criteria, right? So your homework, I asked you which parameters can be adjusted. So I answered the question in few sentences, right? Okay. Now about to run the algorithm. What I expect? Let's think about it this way. So let's start. So here is the narrate. Notice what's happening here. Easy to see it? I don't know. Why do you think it's so cluttered? Because I have too many attributes, right? So what I'm going to do is I'm going to start actually pointing it is these two right here, learning rate and momentum. I can change it to runtime if I'm interested, but first I'm going to start. But it stopped because it reached 5 cycles, right? So it's going to go until this error is small enough, or until I reach a specified number of cycles. Except, or I go ahead and perhaps change my momentum to 0.3, and I'm going to start it on again, but here hit accept. Oops, again. So again, I'm getting it twice because the first time I got it for the training data, and here my test data. So here I could change this to 100 perhaps. Let's see that doesn't. And I'm going to click start. Each and at any time, if I wanted to stop, I can hit stop. Or hit accept. 0. Now here I see my result. And what I do is to analyze. So basically, here relation name, the number of instances, 351, and here the certified is number of attributes. Here, attribute list that was used to run an algorithm. Now, it tells me that I percentage split this option. Here, actual representation of a model that I understand is really hard for you guys to read, right? So basically, it's telling you which input enters every node in a given layer. Skip that. Oops. So here I have two classes. I have two nodes as expected, right? One class. Now this is very important. It shows you percentage of instances classified correctly and incorrectly in the couple statistics and relative absolute error, which are discussed in your book in detail. Here is my confusion matrix. What this is that you have two classes, right? Size is 2 by 2. The confusion matrix depends on the number of classes that I have. So here, the type here, AB means the classified S, and here is an actual class. So one of the intersection. So I have instances of A classified as class A, right? So if not class A, C5 refers to positive, right? So that's basically it is true positive. And here it just computing the rate, right? You have the for how to compute each one, right? Basically, it's gonna be for precision rather. You're gonna do it's a true positive divided by the sum of true positive and false positive, which would be the column, right? So it's 5 divided by 30. So that's how you get this number. I'm showing you guys how to get this number, right? And in the document, I just picked one class and I did the calculations for you just to show you, so you get an idea of what those numbers are, right? Here, what you want to know is that number is close 0.5. The prediction might be biased, and number you want to have a number close on. It means that the algorithm predicts the class, right? Also, the graph, the classification errors, right click. You can classify errors. I'm not in the detail, but you have a predicted class and the actual class, and a different color code for each class, and you have different notation for the instance classified and misclassified, everyone grabs the right area. So if you do that for your project, you're going to visualize risk curve, and you're going to that you want to choose that. Right, that it's false positive rate for x-axis and a true positive for y-axis. Right? So now, very important, these statistics are only for classification. In prediction, if you're doing a prediction, no, you get these two steps, right? So notice that in the optional exercise, in regression, asking you to think about the differences in options that you get for prediction and for classification. For prediction, you're not going to get these two sections, and you're going to have this option enabled. Right? Done so far?
Question?
Sure.
So which part is prediction again?
There's another algorithm, optional exercise. Use linear regression. That one is a prediction because you're actually predicting a specific value. You're predicting a class.
I thought you said there was both parts in here. So it really has to do with what the intention of the algorithm is, right?
Exactly, because when you do the linear regression, you're not going to get these two sections. Because last semester, I got a question from some students who were doing prediction. They asked me, is a true positive and from the output? Where is my confusion matrix in the output? I ended up explaining that this part you're only going to get if you're doing classification problem. If you're doing a prediction, you want to focus your comparison on the errors, root squared error, relative absolute error, and so on. So you want to focus on this part. Right. Mm-hmm. Go ahead.
I have a follow-up question. We do have some time today. Can we go over looking at the results of the prediction? Just basic areas.
We can do that. We can do the regression, right? Linear regression. Yeah. Anyone actually? Some students last semester they used this pattern for prediction too. You have one output node, and you're gonna have hidden layers. You're gonna have an input node, but then it's not gonna be in there. But you did that, which was interesting. Yeah. So I have prediction. For instance, if your data set is predicting the byte percentage, something like that. Also predicting perhaps college graduation rate. Somebody did that last semester. Yeah. And speaking of that, what's happening is that I have a lot of attributes, right? Yes, see this? Select attributes. We'll hit start and show me which attributes are the most relevant, right? So those are the attributes I want to pick, and I remove the rest. I'm going to see how it's going to perhaps, right? And reduce the algorithm execution time. So it's this way, or there is an alternative way. You go to preprocess, and we choose, and I've seen a filter in the right attribute. There is the attribute selection. Right? So select this option here, any algorithms, but we're going to hit apply. See there, I have a reduced set of attributes. Now I'm going to go to classify, and on the same percentage test plate, and I hit start. Oops. Easier to read, much easier to read, right? So I'm going to hit start. Yep. Second time, stop, and up here. Yeah. So here was the fire, right? So there is such a thing as information loss, and I discussed in your textbook, right? Stop by accident removing an attribute that's actually significant. Yeah. The point is that you're developing a sparse model. Right? Your project, it says, discuss an approach to develop a sparse model. Yeah. That's a classification. Now, note that if I go here, the purpose of demonstration, I go here, what happens? I try to do the linear regression. Is it going to let me? Is it going to see this? Is it going to let me? It goes, right? Work it out. Because what happens to my dependent variable? It's not. But the requirement is that it needs to be continuous. So I need to find a data set where you can guys come with your with the backup installation, but I'm wondering if one here, probably not. I'm gonna find one. Basically, while looking for the data set, do you got any questions that I can throw while I'm looking for the data set? Can answer while I'm looking for the data set?
This, and I apologize, I had to walk away for a second.
No.
66%. So we do the split. Second time you ran it, maybe it's what you did. To read again with our test, do you just rerun it again, or do you go up at top and select test set?
Oh, the window is going to open by itself. I didn't really do anything.
I don't realize that. I got to do it again. I don't remember seeing it.
Oh, you need to turn the graphical user interface option on.
Okay, so if you don't have the okay, makes sense.
Yes, looking, yeah. So, other question while I'm still, see here, regression data set. Let me see if I can find one. Oh, I found housing. It's good. And while I'm still looking for the data set.
I have a question. It might be a silly question, but you said that the option was grayed out because the dependent variable was not continuous. How do you see that?
If you go look at this, see this? Yes, right? So basically, I have two possible values, right? The possible values are looking at the wrong data set. So my fault. So now look at this one right here. So I'm gonna go to pre-process. See, the only two possible values are D and G, right? So discrete. This means where I have two distinct values, right? That means that any value in the interval, so to speak, is a valid value. Like for instance, if I so write it down as 2.5-year-old, 2-year-old, right? So it's continuous. There is no, we can easily what is it, are valid, right? So you're not really, you don't of, that makes sense?
screen keeps coming almost like a checkered pattern.
Because I'm looking for the data that I can use for the, okay, here we go. On the car data set. Understand? Oops. Yeah, because I'm looking at what, all right. Here, do you guys see this?
No, the new application.
Oh. Oh.
Yes.
Right. Oh, the first data set. Oh, there it is here. Okay.
Yes.
Okay, good.
This-
Now, yeah. What I'll do is, just for the purpose of this, I'm trying to predict the miles per gallon. What I'll do is see this attribute, unfortunately, is the first on the list. But if I keep it here, it's very easy to forget to change, right? By default, it thinks that the attribute I want to predict is my list. So what I do here is, it's very tricky, but I'll show you the trick. I click on it, right? And here, I'm going to click here, and the class. I'm clicking, and here, option to make it as a class. Oops. Here, this as class. So what happened was it moved, and, right? I'm like, okay. So now, what I want, I want miles per gallon attribute to be at the end. So it just in a histogram because I'm working with and that's not miles per gallon is no longer this, right? And how I know that? Because the statistics are different, showing the minimum, maximum, mean, and the deviation. So I'm going to classify, right? I'm going to hit choose, and I'm back to the function. And this now I have linear regression table. Here. So now if I go back here and I select more options, what happens? It goes. And what's grayed out? Because this is only for classification, right? In my case, I'm not doing the classification. Just miles per gallon is continuous. 45 is valid, 35.4 is valid, 35.6 is valid. So I don't have a specified set of values, all right? We know what the exact set of valid values is. So select OK, and it has built-in attribute selection already. So if M5 method, and see if you do capabilities, it's going to tell you that has to be the numeric. Now, values are acceptable. It tells me require data types for the rest of the attributes, but it says numeric. That it was grayed out before, right? And I close this. I'm going to click OK, and I'm going to hit start. There we go. We got right now the difference because I don't see the confusion matrix in my result. I see the detailed accuracy by class. What it is it. Guys, would you please put it on mute when you're not speaking? Thank you. So what it's doing is it's going to express the on equation. Or his numbers are the coefficients, and he's an intercept. And this telling me that's a weight. Right? This is the year. But here, origin is categoric variable, right? So only one class of is 2 or 3 use this coefficient, right? So actually what I can do is suppose that I have total instance. I'm going to predict my gallon, these variables. What I'll just do is substitute in this equation. And you compare the values that this equation gives with the value in your data set, and that's why you get the errors. Right? A little bit different from classification because it predicts a value, right? You got an intercept and you got the coefficient. So basically what the coefficient means is that you keep everything else constant and change weight by 1 unit. This is per gallon. Change my weight by 1 unit. This change in miles per gallon. And here, it deals with the selection for me because here, not have to depend on a data set, but it's possible that you're not going to see every attribute in here. As you select no attribute selection, here, the option I can select, I can set this. And again, I'm going to say start. See that it's all different? Different? All right. And you discuss this in your paper. Yeah. And it's the first it appears twice, so basically it's only which coefficient I'm going to depending on the value. And if you look here, source is a class. That's a category. How do I know? Because it's telling me the values and the number of instances that value. This is a histogram again. Right. So that makes sense? And yes, go ahead.
Looking at that information, like if you were given the number of liters, the horsepower, etc., how would you determine the miles per gallon? Like let's say, if just so I know how the numbers all work together, if you were given information for everything along the cylinders, displacement, horsepower, how would you be able to use that to determine miles per gallon?
There, I'm going to substitute here. So I know my weight, I'm going to put the weight instead here. I know my horsepower, I'm going to put it here. And suppose the cylinders is 4, right? So what I have is that I have this coefficient, and then I have this one here because it's 4. It applies to 4, right?
Okay.
Basically, you take in a sum, you substitute and you take the sum. I'm going to go and compare with an actual value. Yeah. Or if you use the optional exercise just for your practice, you can plug it in, right? And here, and you do it, and you can just practice. Yeah. So, makes sense?
Like, so you're saying is we just do a multiplication based on those coefficients, and that's where they're all 4 cylinders. We would apply them by those percentages and then add them all up.
Well, the coefficient, yeah, the coefficients, right? And here are the values, right? So if you have 4 cylinders, this is assumed to be 1. 2 cylinders, then this is treated as 0. Because variable, remember?
I understand. I'm just wondering how we actually do it. So, okay. Just multiplying the coefficients times we had received for those.
This is actually in. Yeah, and all of this error.
To clarify, Mike, if you in the book in page 355, there what exactly WCA does. WCA calculates all these coefficients we then show in the previous screen. All these coefficients minus all these coefficients are calculated by WCA by the algorithm, which is linear regression, and behind is the formula 650. 640 up in the book. But we focus, as I stated in the beginning, in the mathematics. That's why, I mean, you have the idea, you read the textbook, you don't remember the formula, and the software is doing this for you. You just got the idea of the reading, not a strong understanding of the math. Is it clear now?
And thank you.
And for the non-linear regression, it's just more complicated math. You can find also in articles, just ask WCA with the algorithm of this. So you understand now why first you have to complete the reading to get understanding and then do it. It's going to be easier, believe me.
Mm-hmm. Yeah.
Something?
Mm-hmm.
For interrupting, we are just running out of the time, but no problem. We can stay more time with more questions, okay?
Yeah, I really appreciate Elena because, well, it helps me also, I would say. But, yeah, different way to explain it. Yeah.
Okay.
Yeah. So, so basically, what I want you guys to focus on homework is to get the concept. So ask you what multi-layer perceptron, and what I'm really looking for is multi-layer perceptron is a WCA implementation of neural network which consists of the input nodes, output nodes, and right? Input node corresponds to the value of the input variable. Output node in case is a class, right? And it's going to be the function of state and input, right? So if you notice that in a perceptron, you have every single input node connected to a layer node. That's a big difference with the symmetries, right? So that's, and here you can specify the number of hidden layers. You can find the number of nodes in hidden layers. Right? And in the book, it says that the neural networks can be used for classification and prediction. The tree is only classification. So this, and that could be summarized in one paragraph. I would like to make sure that you understand what are input parameters, what results am I going to get, and what am I expecting, what do I get. Right? In homework assignment, you also ask to compare. So what there, and you look at the accuracy, right? Look if each model predicted all classes, I can have 6 classes, and it's possible that the model didn't predict a certain class, maybe because it didn't have enough instances of the class, and so on. Right? Wrong, but I'm looking at the analysis rather than single sentence. Another reason I put these questions in is because before just repeat an exercise on a set assigned to a study group, what I think people do is they're going to take the Word document, copy and paste, and just replace the screenshot, but doesn't count. I want to make sure that you guys understand what you're doing and to see excellent reports, of course, on a project, right? You have a question?
A question, but not about this group assignment, but about the bibliography assignment. Expected term bibliography related to our individual paper, and I wanted to know if there's a limit. I mean, supposed to, like in other courses, we were expected to take at least 20 papers used. So is in this one also, or I don't see myself going to 20 paper get information because this was very hands-on. Utilize this research paper. I would know if there's a limit here.
She rather doesn't want to tell us. So,
Okay.
no, she's asking
Take
about,
away. What is the question?
she's asking about me on number of references.
The number of what?
Not pages that the paper needs to be.
Oh, there is not such a suggestion.
I'm sorry.
Equality. I can tell you. In order to present something for this, it's also how many screenshots you are going to put, which doesn't count towards the text. You know me? Your real text is not going to be more than 50 pages. But no, if you start counting all these screenshots, figures, there is not limitation. Just text, your own word, I expect more than 50 pages. I think 15 is maximum you can produce in a semester this length week. So keep in mind this. On top, your own analysis, cooperation, it's gonna be between 12-15 maximum pages. Without references, screenshots, your introduction, bibliography, research, whatever. I'm not counting. I'm talking about your own research. It's not going to be too much. So that's not suggested length. The most important is that I can see when I read your report of the research, I can see you understand you did something important and you can interpret the results of two different algorithms. That's the most important part. That's why we focus now in the group assignment, interacting the results. That's the most important. Not just doing and look into something in the screen. The problem is what you see there, what it is. That's what we are trying to make you understand. And that is what you are going to take for this class. I mean, your investment of time, of money, of everything is what is this understanding? What are the expectations? Did I answer your question?
Yes, sir, but mine was more like for the bibliography limit, but I think you've asked that one.
Limit. No, not quality.
I would probably have a screenshot of the regression model, right? And explain what these are, what it is, and so on. Yeah, it's a good one. Right here, I would have explained it. Yeah. So, for example, and when you did the classification, perhaps you would want to do a screenshot of the confusion matrix, the screen of the detailed accuracy by class, and the example right here, right? They would not want this because I've seen people copy this about several pages, but if you do think you want to include it, you put it in the appendix or something. But this here, that's what you want, this section, right? Align it. There is no right or wrong for it. And you would want a visual representation. And line here's my input node, my output, this is hidden layer, etc. Yeah, but make sure the screenshot has a purpose. Because if you look at the Word document, the purpose of the Word document was more like to show you how to do that and explain it's a double purpose. But I'm assuming you guys know how to do it, but show why you're doing it. Well, that's
Talking about value, we're solving a business problem. And that's where the value would come in?
Well, an understanding in this case, you want to show that you understand what a regression is. You want to show that you understand what parameters it take, what's the purpose of the exercise.
But I'm thinking, and actually I'm kind of going where Deepa was going. I'm thinking of the research paper, writing up my research paper, and in theory each week, because a group is kind of like a research paper. I'm thinking deeper, and what I mean by that is, it's what are all the pieces that make it run, and it's really how do we apply it at the correct?
But you want to explain exactly what you're doing and you're doing it. But for the project, it's more because here you would need to look at related studies and you need to explain the data itself and like for example, my study is to for the body fat percentage based on measures. To do this, I'm going to use this and this and this algorithm. Here my data pre-processing steps. Here shows this algorithm because, and here we have your explanation, right? That's the output, you have comparison, and then you pick every study, and you say the author X, just in a generic example, study on this and this, and this is the method that he used. Here are his results, compare. For logarithmic regression, there could be quadratic regression, there could be other methods that's not available in Vector, but that's fine. Value to your paper also.
Going back to one of the questions I posted, not something we give to a customer. Because I go like that into a customer would throw at me and say, what you mean. So this is more of a technical document provide to a customer.
Well, this is an environment where you're just learning what the algorithm is.
Right.
Yeah, at work is more complicated than this, absolutely. It's in the basics.
See, I think work is simpler.
Not, I would like to.
Let me see, I got, what I understand by my question is regarding the project, right?
Yeah, he wants to,
And let me tell you, your project, the final product of your project for this class is not business project, it's more technical. This is not a project to show to the customer. And this technical part, so I have to interpret and extract the business part, but this is beyond this course.
Agreed. I'm agreeing with you. That was my interpretation from this piece, is that this is more of the better term, the statistician doing something in the background before the marketing team to interpolate.
Yeah.
here is the quality. You want it to be well written, that's what I was trying to say. You need to have an introduction, you need to have a conclusion, and it needs to show the graduate level of writing. That part is yes. That makes
From you. The answer is yes. No, makes totally sense. A lot.
yeah, for graduate level writing, which is different from the writing that you would normally use on a Facebook or in the emails, right?
Definitely. Well, even writing to a customer limits to graduate writing. Right. What I wanted clarification on, and you both provided it, and I appreciate it, is this more of the technical statistician document, marketing document, where somebody's going back to a client saying, here's a recommendation.
Mm-hmm.
This is more the technical piece.
Right.
Technical piece must conclude with the thing which leads to the business. It's document, but the conclusion should be exactly this, Mike.
Right, the recommendation.
Yes. very extensive, like conclusions, let's say, half-page conclusion is right on any limit. You can write. Okay. Oh,
Okay.
dear. Okay. Here's not more questions. This session was helpful. If we needed, if you find this session helpful, just send us email so we can schedule with time. This week is more complicated for me because I have conference, but I will set everything and answer question, whatever is needed.
Rems, I'm trying to make the selection of your algorithm. Choose algorithm. What if you make you choose an algorithm that's not really suitable for your data, but you are capable?
I will ask you in 2 weeks. You should be working now in your research project, and I expect in a week or so that you can tell me how you have advanced in your project and what algorithm you choose for this data set. And if you are not in the right direction, you are going to get our feedback. We are going to correct you on time. But in order to be able to do this, you should be working now. And we're asking you to provide your progress in research project. You can tell me, I choose this because of this, and you will be corrected. You will get our feedback. This shouldn't happen.
Yeah.
More questions? More questions? We'll end the session and have a nice evening. In the weekend, and of course, have a productive weekend.
Thank you.
Thank you.